Hello, this is Scholar Strive doing some math today in geometry. We're going to be using similar polygons. So what is a similar polygons? Two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. So let's say we have a triangle here and that kind of looks like that. And then we have a bigger triangle, but it kind of looks the same. Its corresponding angles are congruent. So if I called this ABC and DEF, we would say ABC, triangle ABC, is similar, so just one squiggly line, to triangle DEF. So angle A would need to be congruent to angle D. Angle B would need to be congruent to angle E. And angle C would need to be congruent to angle F. And then the sides need to be proportional. And what that means is AB over DE needs to be equal to BC over EF, which equals CA to FD. So scale factor, the ratio of the lengths of the corresponding sides of similar polygons, is the scale factor. So let's do, let's do these same two triangles again. Small one, bigger one. Let's call this 3, 4, 5, and 6, 8. Let's see. 6, if I can do this right. There we go. 6, 8, 10. The scale factor in this case would be 3 over 6, which is the same thing as 4 over 8, which is the same thing as 5 over 10. So you look at one of the corresponding sides, and these all equal 1/2. So the scale factor in this case is 1/2. You could say that the big triangle is 2 times bigger than the small one, or you can say the small one is half the size of the big one. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their sides. So, if we look at the perimeter of this small triangle here, perimeter means to add up all the sides. 3 plus 4 plus 5. So that's 7 plus 5, which is 12. And then perimeter of the big triangle here, 6 plus 8 plus 10 is 24. Notice that 12 over 24 is also 1/2. So the ratio of the perimeters is equal to the ratio of their sides, or the scale factor. If two polygons are similar, then the ratio of any of their corresponding lengths is equal to the ratio of their sides. Alright, let's work on some examples. Name all pairs of corresponding angles. Okay. So they tell you that these triangles are similar. So one easy way to look at it is the first letter is always corresponding to the first letter of the other triangle. So angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Now you even have to look at the picture. But if you look at the picture here, well, if this triangle was, there we go, the 10 AB, the length of AB is corresponding to the length of DE, because it's the left side, the bottom is the 12 and 18, and the right side is the 8 and 12. List the ratios of corresponding sides. Are the ratios equal? Now these should be, but I'm going to list them out. AB over DE. So those are the corresponding sides, and that is 10 over 15. And if we reduce that, that gives us 2 over 3. Now let's look at the other sides, BC and EF, and CA and FD. So the right side, comparing the right side of the small triangle, is 8 over the right side of the big triangle, which is 12. That is also 2 over 3. And then lastly, the bottom of the small triangle is 12, and the bottom of the big triangle is 18. That's also 2 over 3 if you divide by 6. So yes, the ratios are equal. Write a statement of proportionality for the corresponding sides. So in this case, we would say AB over DE is equal to BC over EF, which is equal to CA over FD. Checkpoint 1, given, so again, so we don't even need a picture for this one, but remember angle P is going to be congruent to angle X, so that's the first letter. Second letter is Q and Y. And then last letter R is congruent to angle Z. And then the proportionality of the sides, PQ. So the first 2 letters. And then QR, the last 2 letters. And then the first letter and the last letter. RP or PR. If you're going around in a circle, it'd be RP. And then ZX. Alright, let's move on. Given BCD is similar to RST, find the value of X. Okay, we know that these triangles are similar. So I'm going to use ratios here. So the long side of the small triangle is 13, and the long side of the big triangle is X. So I'm going to say 13 over X. That's going to be equal to the ratio of one of the other sides. So I'm going to choose, you can choose the left side or the bottom, it doesn't matter which, as long as you keep the numbers right. So let me write this out. I'm going to say right side of small, right side of big is equal to bottom of small over bottom of big. So whenever you're creating your proportions, you always want to make sure you're always comparing one triangle to the other. So what I did was I was comparing the right side of the small triangle over the right side of the big triangle, and then we're going to compare that to 2 known sides, so we know the bottom ones. So bottom of small, bottom of big. See how the smalls are on top and the big are on bottom. So always keep your numbers in order. So when I put this all into order, 13 over X is equal to 5 over 10. So I'm going to do my cross multiplication. But first, I'm going to reduce this. So when I reduce this, 13 over x equals 1/2. So now I can do my cross multiplication. So 13 times 2 equals 1 times x. So x equals 26. A basketball court is being enlarged by adding more flooring to the original length and width. The new larger court will be 25 feet by 20 feet wide. The original smaller court is similar in shape, but is only 16 wide, so we have a smaller rectangle, 16 wide. How much did the width increase by? Okay. 4 feet. Because we know that the width of the big is 20 feet and the width of the small is 16, so the difference is 4 feet. What is the perimeter of the new larger court? So they gave us the dimensions, so we're going to add up all the sides. 25 plus 20 plus 25 plus 20. And that'll give us 50 plus 90, or 40, which is 90. What is the perimeter of the smaller court? So now we need to make our proportion. So I'm going to do length of big over length of small equals width of big over width of small. So I'm going to put in my numbers. So the length of the big one is 25. We want to know the length of the small. So we're going to call that x equals length of the width of the big, which is 20, over width of the small, which is 16. Now when I reduce this, I get 25 over x equals 5 over 4. So then, cross multiply, I'll get 5x equals 100. That's 25 times 4. Divide by 5, and I'll get x equals 20. So now that we know what x is, the perimeter of the smaller court is going to be 20 plus 20 plus 16 plus 16, which is 72 units, or 72 feet. So 90 feet to 72 feet. The triangle FGH, so this really big triangle here, so I'll overlap it with this black ink right here. So that's FGH, is similar to triangle JGK, so this one. Use the scale factor to find the length of the altitude GL. Okay. So looking at the red, so we're going to create a proportion in order to find this, because we want to find the height of the whole triangle, the black triangle, the big triangle. So I'm going to say I'm looking for the height of the big triangle. So I'm going to compare that to the height of the small triangle, creating our proportion here. Oops. Equals, so we're going to use two sides that we know of. So we do know the size of the base there. So the length, I'm just going to say the length of the base of the big. So the base of the big here is 8 plus 8, which is 16. And the base of the small. Okay, when I put my numbers in, so this is going to be x over height of the small is 14, or height of this red triangle. The base of the black triangle is 8 plus 8, which is 16. And the base of the red triangle is 10. That's 5 plus 5. I'm going to reduce this so that x over 14 equals 8 over 5. When I multiply this out, I'll get 14 times 8 equals 5x. So 14 times 8 equals 112. And then 112 equals 5x. You divide both sides by 5, and you'll get x is about 22.4. So the height of the big triangle is 22.4 units. Alright, here we go. So they tell you that these triangles are similar. So first thing, we need to find the perimeter of W, X, Y. Okay. So we know from all the way up top is that the ratio of the perimeters is equal to the ratio, or is proportional, yeah, the ratio of the perimeters, so perimeter of the big over perimeter of the small, is equal to the is equal to the proportional side lengths there. Okay, let me go scroll back up. The ratio of the perimeters is equal to the ratio of their sides. There we go. So perimeter of the big over perimeter of the small. You could put perimeter of the small up top and big on the bottom. It doesn't matter how you do it, as long as you keep them in order. Is equal to the ratio of their sides. So let's use two sides that we do know. The big triangle, let's use 72, and the little triangle, we use 40. Because we're using, if I want to put this in word, left side of the big, left side of small. So perimeter of the big is 72 plus 63 plus 81, which is 216. Okay. Over perimeter of the small, that's what we're looking for. Left side of the big is 72 over 40. Do your cross multiplication, or you can reduce it first. If we reduce this, it's going to be 216 over x equals 9 over 5. So now we do our cross multiplication, and we'll get 5x equals 9 times 216. So 5x equals 1944. Divide by 5, and we'll get x is about 1 second. Perimeter of the big. Did I do something wrong here? Oops. I cross-multiplied incorrectly. So when you cross multiplication, it's 5 times 216 equals 9x. Okay, so 9x equals 5 times 216, which is 1080. Divide by 9, get x equals 120. So the reason why I caught myself is because I found out when I was working earlier, I found out that the perimeter of the small triangle is bigger than my big triangle. So that can't be the right answer. So I redid it, and now our perimeter is 120. All right, let's move on to this last problem here. The length of the median. So these tick marks mean that this is 24 and that's 24. That's 16 and that's 16. That means this whole thing is 48 and that is 32. So I'm going to do median of the big over median of the small. So 39 over x is equal to the bottom of the big, which is 48, over bottom of the small, which is 32. So when I cross multiply, I'm going to go 48x equals 39 times 32. So I'll get 48x equals 1248 divided by 48, and you'll get QS being 26. Hopefully this helps you out. Have a good day.